Next video, we're going to look at radicals, okay? Stuff all about radicals. Let's get a little more centered here. Maybe. All right, so a radical is like a square root or a cube root, right? And it's something that your square root looks like that. If it's a cube root, you put a little 3 in there and a 4 and so on. You can go up to, whatever root you want. Okay, so we're going to be talking about these radicals, and you got to be able to simplify the radicals. And we're going to keep doing this. You're going to see it over and over again with our future assignments. So we're just going to practice it, right? What we're going to have to do is make a factor tree. Right, so if I wanted to make a factor tree for 56, I'm going to put some branches on there, and I'm going to rewrite 56 as a product. Okay, so I could pick anything I wanted, right? Like I could say, okay, 56 is even, so I could cut it in half, and half of 56 is 28. So I could say 2 and 28. Or I know that 7 times 8 is 56. Doesn't matter which route you take. Pick something, and then we'll work down from that. So I'm going to go with 7 and 8. So I have broken down 56 to be 7 times 8. 7 is a prime number. I can't do anything with 7, but 8 is not. I can break 8 down to be 2 times 4. All right, 2 is a prime number, but 4 is not. I can break 4 down to be 2 times 2. Right, so here's my factor tree. I've made all my branches go down until I get down to all prime numbers. Right, so 56 is the same as 7 times 2 times 2 times 2. Once I branch out from a number, I don't use that number anymore because I rewrote 4 as 2 times 2. So I don't need that 4. I don't need to think about the 4 anymore. All right, when it comes to our radicals, all right, and when we're going to simplify our radicals, the square root of x is the opposite of x squared. All right, those are opposite functions. They're inverse functions. They cancel each other out, right? Which means when I go to do my factor tree and simplify these radicals, I'm looking for something squared underneath my square root. Because then the square root and the square will cancel each other out, and I can bring out that number, whatever it is that I can square, right? So like, for example, 4 is 2 squared. Right, so if I can rewrite this as a square root of 2 squared, the square root and the 2 cancel, and that's where I get my 2 from. All right, because the square root of 4 is 2. So we're going to keep that in mind when we start to simplify our radicals. All right, so let me change pages and get in here good. All right, so for our first example, I've got the square root of 80. So I'm going to start by making my factor tree. And again, I can pick anything. I know that 2 goes into 80, so I could do 2 and 40. Perfectly fine. I know 5 goes into it because it ends in a 0. Right? We have several different options. I'm going to pick 8 and 10, just because that's what first came to my mind. Okay, neither one of those are prime, so I can rewrite those. 8 I can rewrite as 2 times 4, just like we did. And then I can break 4 down to 2 times 2. Right? 10 is 2 times 5. Now I'm down to all prime numbers at the bottom of my factor tree, right? Remember, I can take out something from the square root as long as I can square it inside the square root. So that means I'm looking for pairs, okay? So I'm going to look for groups of 2, right? Not necessarily the number 2, but I'm looking for pairs. So I have 2 2s right here, and then I have 2 2s over here. But I can't circle the 5 because I don't have a pair. I don't have any more 5s under there, so I can't circle it or anything. And then for everything I circle, I'm going to take 1 out. Right? So I circled 2s here, so I'm going to take out a 2 on the outside. I have another group of 2s, so I'm going to take out a 2. But that 5 I couldn't take out, so I'm going to leave him on the inside. And remember, once I branched out from a number, I don't use it anymore. So I don't need the 8, the 10, or the 4. I ignore those because I rewrote them already. Okay, and then whatever numbers you have, you multiply. So on the outside, I have a 4, and on the inside, I have a 5. Okay, so what I'm going to do is make my factor tree, circle any pairs that I have. Everything I circle, take 1 out. Anything I don't, we leave it on the inside. Then you multiply what's on the outside, multiply what's on the inside, and there's your answer. Okay, so for number 2, I have this huge number, all right? Just start breaking it down. Go with what comes to mind. So I know it ends in a 0. So I'm going to make this 112 times 10. All right, that narrows it down some for me. Okay, the 10 I know I can break into 2 times 5. All right, now 112. I don't really know what goes into 112, but I know it's even, so I can cut it in half. So I'm going to put a 2 there, and then 112 divided by 2 is going to end up being 56. All right, well, 56 we just did. I know that I've got an 8 and a 7, and then 8 is 2 and 4, all right, and then 4 is 2 and 2. So here's all of my prime factors for 1,120. Look for some pairs. I don't have any other 7s, so I can't circle the 7, but I do have 2 2s here, 2 2s here, and I have an odd number. So I can't circle this 2 because I don't have another one, and I can't circle the 5. Okay, and remember, once you branch out from a number, you don't use that number anymore. We ignore those. So for everything you circle, take one out. So I have a circle here, so I'm going to put a 2. I have a circle here, I'm going to put a 2. And then on the inside, I'm left with a 2 and a 5. And then we multiply. So 2 times 2 is 4. 2 times 5 is 10. So this one simplifies to 4 square root 10. We're not changing anything. You can type this number in the calculator and get a decimal, and then you could type 4 square root 10 in the calculator and get that same decimal. We're just simplifying because it makes it easier later on. All right, now 3 and 4 have variables in there. We don't do anything any different, all right, except I'm going to have to take into account that I have 3 x's, okay, and I'm still looking for pairs. So I'm going to start with the number and break down 40. So I'm going to say 4 times 10. Okay, you could have done 2 and 20, 8 and 5. Anything like that would have worked. 4 becomes 2 and 2. 10 becomes 2 and 5. I don't need the 4 and the 10 anymore. And I only have one pair. Okay, before I start writing anything, I'm going to go back to those x's. I have 3 x's, so I'm just going to write my 3 x's over here. Right, and then I'm looking for pairs. Well, I do have 2 x's in there. I can't do anything with that third x, right? But I can circle the 2 x's. For everything circle, take one out. So I'm going to take out a 2. I'm going to take out an x. And on the inside, I've got a 2, a 5, and an x. So we're going to multiply. So we got 2x on the outside, on the inside, 10x. So this one simplifies to 2x root 10x. And then our last one, we got another big number in there, plus some variables. So I'm going to start with the number. Okay, 576 is a big number. I don't know what goes into it, so I know it's even because it ends in a 6. So we're going to divide it by 2. So we've got 288 and 2. Oops. Right, and I know that 288 is a big number, but it's also even. So I'm going to divide that one by 2. I'm just going to keep going until I get to something that I recognize. All right, now I recognize 144. I know that that's 12 times 12. Okay, and I'm going to stop there. I'm going to make my life a little bit easier. Okay, I could break down 12 twice, right, because I know 12 is even, or it's 3 times 4, and I can go from there. But I have 2 12s, right? So once I get down to 2 12s, I'm just going to stop, and I'm going to go ahead and circle those 2 12s. Okay, and then I also have 2 2s, right? And I don't need these guys because I branched out. Okay, and I got 4 x's and 5 y's. Okay, so I've got 2 x's, 2 x's, 2 y's, 2 y's, and I can't circle that guy because I don't have another one. Everything I circle, take one out. So I'm going to take out a 12, take out a 2, right? I'm going to take out an x and another x, and a y, and another y. And then on the inside, all I have left is that one y. Okay, I don't have any numbers left over, and that tells me 576 is a perfect square, right? That means it does have a square root, just like 4 and 16. Okay, then we multiply. 12 times 2 is 24. X times x is x squared. Y times y is y squared. And then I have that lonesome y left on the inside. Okay, so that's simplifying radicals, and we have one other thing to talk about when it comes to our radicals and making sure we simplify, and it's something called rationalizing, okay? You have to rationalize if you have a radical on the bottom. It doesn't matter if it's on top, but it cannot be on the bottom, so we can never leave a radical in the denominator. It's like bad math grammar. So we got to do something called rationalizing, right? And all we do is we end up multiplying to get rid of the radical. Now there's one number you can multiply by that's not going to change your number at all, right? And that's 1. Anything times 1 is itself, so 1's not going to change anything. And if I wanted to write 1 as a fraction, I could write that as 5 over 5 or 4 over 4. Anything on top and bottom, as long as it's the same, that equals 1, right? Because if you divide something by itself, you get 1. So I'm going to multiply by something to get rid of this square root, but I have to make sure that I do it on top and on bottom so that I still multiply by 1. Okay, now if I go back to what we talked about before, if I square a square root, or if I square root something squared, they cancel out. So that means that I can multiply this by itself to square it. Okay, we can't just square it because that would change my problem. I want to multiply it by itself, right? Because if I had like over here, x times x was x squared. So that means that I can take root 5 times root 5, and that's the same as the square root of 5 squared. So that radical and square is going to cancel out. But I have to do it on top and on bottom so that I don't change anything. Okay? So now the square root of 5 times the square root of 5, right, is the square root squared. So the square root goes away and I'm left with just 5 on the bottom. Right? Because again, because I multiply it by itself, that's the same as squaring it, and the square cancels the square root. So I'm left with just a 5. And up top, I can multiply non-radicals. I can multiply radicals, but you can't mix them. Okay, and what I mean by that, let's see, we'll come over, let's change colors. We'll come over here. I can do 3 times 3 and get 9. I can do the square root of 2 times the square root of 5 and get the square root of 10. Those are perfect. But I can't do 3 times the square root of 5. Okay, that doesn't work. You can't mix radical and non-radical. So what we do is we just write it like what we got. This is 3 times the square root of 5, so I'm just going to leave that as 3 root 5. Just like if I did 3 times x. So then my answer is 3 root 5 over 5. Right, so it's the same steps, and there was a lot of explaining to go with it, but it's the same step every time. You can't leave that radical on the bottom. So over here, I'm just going to go ahead and multiply, put that radical on top and on bottom. Every time we do this, the bottom makes the radical go away. So it's just going to be a 3. I cannot combine those up top, so I'm going to write it as 2 root 3. Okay, and then our last one, same thing. I'm going to do a root 6 on top and on bottom. Okay, so then I've got 3 root 6 up top and a 6 on the bottom. And we are almost done, but you got to double check and make sure that you can't simplify it more. Like here, 3 over 5, can't do anything. 2 over 3, can't do anything. But 3 over 6 is 1/2. So this is the same as 1 root 6 over 2, but you don't really need that 1 there. So it would just be root 6 divided by 2. And again, I can't divide that because 1's a radical and 1 is not.